section that actually does not even exist in the old version of the Edexcel Pearson textbook, but it's in some of the new version. It's in all the new in the section 11.8, and it comes under the section finding areas under parametric curves. Okay, so I'm just going to go through this example. So we have a couple of parametric equations, and you have already met parametric equations in the differentiation chapter. Now, parametric equations are set of equations which have got an additional parameter. For example, x is defined in terms of t and y is also defined in terms of t. Okay, if I did not have the t in my equation, then I would just have a Cartesian equation, which would be y equals and anything in terms of x. Okay, but the problem here is I've got two equations, they're parametric equations, and I've got to find the exact area. So find the exact area, and I've got to find them between x is 0 and x is 2, and they've also given us a graph. The graph looks something like this. It's for a curve C, and I've got to work out this area which is shaded, okay, between 0 and 2. Okay, so what I am going to do is I am actually going to use the formula for area under curves, which is that, you know, we integrate the function, the y function with respect to x. Problem here is I don't have a y function with respect to x. Okay, so what I'm going to do is I am actually going to use my chain rule. Okay, so I'm going to write y dx by dt, and I'm going to integrate that with respect to t. Okay, by doing this, I've actually not, dividing by dt and multiplying by dt has actually done nothing to this overall. Okay, so what I've got to find is dx by dt. So my x is t plus t squared. Dx by dt is 1 plus 2t. Okay, and I am now going to plug this into my formula here. So I'm integrating y, which is 1 over 1 plus t, and I'm going to multiply that by 1 plus 2t, and I'm going to integrate that by with respect to t. Okay, the other thing that I have to do is I've got to switch my limits. So I can't use my limits 0 to 2, okay, because the limits here are for x and I need limits for t. Okay, so why not I find those limits? So when x is 0, this is the equation that I'm actually trying to solve. So t is equal to 0 or t is equal to minus 1. Now it does say that t is a positive. The question gives us this condition. So obviously this can't be the one that I'm looking for. So t must be 0. So when x is 0, t is 0. And the other limit is when x is 2. So t squared plus t equals 2. T squared plus t minus 2 equals 0. And then if I factorize it, I am going to get t plus 2, t minus 1. So obviously I'm going to ignore the negative and I'm going to go with t is equal to 1. So t must be equal to 1. Okay, and the next thing I need to do is I need to integrate this. Okay, now you should be able to spot that this is an improper algebraic fraction. Okay, and I will have to separate this out using partial fractions before I can integrate this. Okay, so I need to convert this into a mixed fraction, a mixed algebraic fraction. So what I'll do is I'll do one step long division. Okay, so t plus 1, how many t plus 1s can go into 2t plus 1? Twice. So 2t plus 2, subtract, and I get minus 1. So I can break this fraction down into something that looks like this. Okay, and I have to integrate this with respect to t. And this is something that I can integrate really easily. So I'm going to get 2t minus ln t plus 1, and my limits are 1 and 0. So I will now substitute my limits in. I'll get 2 minus ln 2 minus 0 minus ln 1, which gives me 0. So I'll get 2 minus ln 2 as the area. Okay?